Alright, sorry to tell you just now, but we do have resource pages, so I'll pass them. Now, one of the things that I would love to do one of these days is have the time to train for a race. What? Now, I'm just telling a story. So, if you were going to do a triathlon, the standard triathlon consists of running, don't know why people run when they're not being chased, swimming, we all like being in water because that's our natural state, and cycling. So here we have some data on some cyclists. This graph, or these graphs, more so, show the relationship in their distance compared to time. What about what?
Wait, is it true that they have to do that as practices? Is it true that they have to do that for practices?
I mean, for Olympic triathlons, yeah, you gotta practice like intense. Alright, so here's what's up. We want to use this graph that I just gave you to determine the unit rate.
Good afternoon.
Unit
Oliver
rate
Long, please come to the
because
office.
of.
Oliver Long, please come to the office. Thank you.
I am not on the
I know, but I heard Oliver and my just immediate reaction. So, unit rate is called unit because one. So you want to calculate the miles per hour for each of these athletes. I'm going to give you a couple minutes to try this. Using the graph and the data in front of you. All four, A, B, C, D. They are labeled out to the right on your page. Your page is going to be easier to look at than this.
Oh,
Yeah.
it's on here.
Using the data you have.
Wow, I am.
Wow.
Yeah, sure. I see.
Does not take your mouth to figure out the unit rate. Your mouth. People are talking. It's not helping. Oh, so I lied about miles. I forgot the word metric system here. So we're talking kilometers. Kilometers per minute, or kilometers per hour. Or per hour. I mean, once we know per minute, we can convert to per hour real easy. No. Can anyone make a statement about what you immediately notice from the graph? A has started. So wait, what does that mean? Not necessarily he's achieved. He had a head start. For some reason, Cyclist A had a head start. He was at the cafe like 7 miles into the race, and he was like, I got a good idea. We'll just start right here. Alex?
That he starts at 6 minutes.
And D
I mean,
couldn't get.
what?
B?
What?
B had a shoe issue or something. Like, seriously, if you're cycling, you gotta like wear these clip-in shoes, and it could be an issue. He started at 6 minutes. So be careful when you're computing their unit rates that you realize he started with distance already covered. He started with time already allotted. We're gonna want per hour. I mean, you can do per minute, and then we can convert.
Well, you can make me I think I'm doing this wrong, but I'm still gonna do it. Yeah, me too. So what did I just calculate?
No, the area inside of it don't matter. That's you like from that point to that point, it went a change of x of 6. So it took 6 minutes to go 4 more kilometers. So think about what the triangles are representing here. This triangle is 6 minutes to go 4 kilometers. So for cyclist A, his speed, always distance over time, we have 4 kilometers over 6 minutes. Now wait a minute. But if we want to reference per hour,
So we are doing per hour?
you need to. I mean, if we're going to talk about speed, we don't really ever talk about speed per minute. I mean, with small experiments and things like that, you might talk per second or per minute. But if we're talking about a cyclist, how fast they're going, we're going to be referencing per hour. 40, right? Because times 10. This is not actually 1. It's 60.
No, I got that, yeah, but...
Sorry, not times 60, times 10. To get to 60, because this is actually 60. What's your confusion?
Why did you use the 2 numbers at the triangle? Because can't you just look at a point where the line crosses the limit to that and find it?
Sure, let's try that. So, right here. So that point, right? That is 15 kilometers, and it took him 12 minutes. And times 5 would be... Alright, give me your eyes up here. Bilal and I are facing an issue. We're confused. Because Bilal said, no, wait, I can't, what are you doing with the triangle? Why, like, you're wasting time. Can't I just take a point? And now he called me a dummy, too, while he was at it. He said I smell bad. So, Bilal said, if I have a point and I have distance and time from the point, can't I just set them up?
You'll get the same answer.
But I didn't. That's our confusion, right? Like that's why we're confused. Because we did it. Not a straight line. He didn't speed up.
He can speed up.
Right, the line would change.
You know what? He sped up. You know what? I was just thinking first divide those both by 3 and then we can get 5 over 4.
Divide them both by 3. For what?
15 and 12 there.
Who what?
Divide 15 and 12 by 3.
Okay, but I mean that doesn't really change. I went from 12 minutes to an hour, so I did times 5. So we did times 5. Like to go to an hour, be careful because I'm unit changing on the bottom. You don't need to. You can do over 60 minutes, but I'm trying to get you guys to be aware of these things. I'm unit changing on purpose to like take your understanding of proportions even further. Will? Okay, we're not moving on to another different way until we figure out what's going on here.
Asking a question. He's confused and Bilal is confused. And we're all confused. And I'm asking confused.
Good afternoon.
I had the full
Yeah.
That's like the slope. That's just one point when you play around the slope, you have these 2 points. Thank you. You know what are you doing? Are you going to didn't he use 2 points? Do we trust me now? What?
This is totally wrong.
Yeah.
Because he cheated. He's not actually traveling 75 kilometers an hour. It only looks like that because he cheated. Hold on. This is where y-intercepts really screw with you. So this, although it could potentially work in a different situation, because this dude cheated and started 7 miles in, we cannot just take a point. Now, hold on. Hang on to it for a second. Bilal's not wrong, though. The problem is he's trying to work with a cheater, and Bilal's an honest person. Annie?
Okay, so can you mark the point you just marked and figured out he's lying? You're lying.
Can you just like subtract that?
Okay, and then mark the point where the triangle meets. Can you do that? And like,
Yeah, but Bilal was asking why was I using a triangle. Now you're just using a triangle.
oh, okay.
So, the point.
We don't like triangles. Why do I keep throwing my pencil? Stop! Did you do it?
So, make sure we're not putting all our effort into taping. I just have my tape for a while. The point of what I'm trying to show you is this. You can do what Bilal just asked me, but only if he starts at the origin. So, for cyclist C, let's follow this guy. If I choose any point that intersects, and I think that's a perfect intersection. I say that
All of
probably
them
is.
are off. All of them are off.
All of them are, well, these are not off. These are perfect intersections. Then that has to be. If these are, then that has to be also. Yeah. So, I can look at this triangle, 2 and 3, or if I take the Bilal method and look at this point being, well, careful, x, y, right? Yeah, 12, but not 12 over. X, 12 and 8. But then it's change in y, right? Your distance over time. So distance was 8. I should have really changed colors here. So C's 8 over 12, right? 8 kilometers in 12 minutes.
Wait, he's going to.
Or
What's wrong?
this triangle right here, 3 compared to 2, he went a distance of 2 kilometers in a time of 3. Same fractions, right? 8 twelfths and 2/3 are the same thing.
So all you need is the triangle to solve it. They're all going 40 kilometers an hour.
Not all.
Oh wait. Wait, I have a question.
So C is also at 40 kilometers per hour. Notice the graph shows us this. Will? I don't know. You had your hand up.
So like my method of solving it was basically it works for this graph, but it's not gonna work for everyone because some like
And it's not a good method.
yeah, it works for this one particular though. Basically just like kind of follow with your eyes and then like for like to see just wait till it gets to like 100 place like for here it stops at 1.5 and then it goes 1 meter or not 1 meter, 1 kilometer in 1.5 minutes.
Well, that sounds like it could work for any situation. Why are you saying it won't work for any situation?
Because I don't know. I feel like what I was thinking when I said that was like some graphs might go through like weird.
So hang on to that thought, okay? Hang on to that thought. Rachel?
Why did you make it 46?
Because I needed to turn this into 60 minutes to be an hour.
Oh, okay.
And I multiplied by 20, which took me to 40. So 40 kilometers per 1 hour. Yeah,
So all you need is the triangle.
points.
Okay, and so you know how that 3-minute triangle thing you labeled it hits the point at 9 minutes? You don't need to know that.
Nope. So here's what we're doing. If he is riding in a straight line, he's consistent. His speed does not change. So for B, although he doesn't start the race on time, that doesn't affect his speed. That affects when he finishes and like he's gonna lose. But yeah, look at this. B actually ends up passing C. So hold on. I feel like some of you haven't done this and you've just been kind of watching or dancing and writing things down. We need to look at the difference in the whatever units you're working with. So 3 minutes compares to 3 kilometers. So he is writing, we do distance over time, 1 kilometer over 1 minute, because I could do 3 over 3. Now, the other way to get there. Hang on. You're whispering. Because here's what you're asking below. The info of where the points actually are. This point is 8, 2. And this point is 11, 5. No, XY. XY.
Oh, yeah, right.
What is your change in the X value?
3.
What is the change in the Y value?
Oh, so the
Your
triangle.
rule for slope. This you definitely want to write down. Is represented by the letter M. Don't really ask me why, I forget.
Oh.
Alex?
It's equal, it's M, Y, it's Y, well, the change in Y over the change of X equals M.
Wait, yeah, we
That means change.
y2 minus y1.
I know you guys have already done this in science.
Yeah.
Wait, Y squared?
Nope. Y base 2, meaning the second Y value that you have. This is your secondary point. This is your first point, right? So 11 minus 8 and 5 minus 2. That's how we get the 3 and the 3. So if you don't want to make the triangle and you just have 2 points, what's the change in Y? What's the change in X? Do the division. So our last writer that we haven't calculated here, writer D,
Oh, I almost got it.
we have a triangle down here. What's your delta Y?
It's 30.
2. What's your delta X?
4.
So we get essentially 1/2.
Yeah, which is 30, 60. So that would be 30 miles. 30 kilometers.
So yeah, his speed's really 30 kilometers per hour. So we have speeds of 40, 40, 30, and yeah, B's was 60.
Wait, so can you scroll down to the equation? So let's just say if y2 was 6 and y1 was 3, okay?
Yeah.
So then the y change and the change in x would be 3 over 3,
Mhm.
and then you do the division, right? Wouldn't be the fraction.
I mean, the fraction is one way to represent the slope. Like some people might say the slope is 5/4. You would not say the slope is 1.25. You could, but you don't. If we're talking about slope, we're more than happy to use the fraction because the fraction tells you the rise and the run, right? So if you present it in fraction form, it's almost easy.
Oh, yeah. 'Cause x.
Yeah, it tells you this much up, this much over, right? Your fraction tells you up and over. Let's try some more.
I had a question too. I forgot it completely. Whoa!
Because they were mad at me that I made them forget their question.
They're mad at you about it.
Why? We're having conversations. Why is it hard to compare writer A and writer B? And we already kind of talked about this, Boo.
Well, because A had a head start and B had a late start, and they only have like a minute difference, or not a minute difference, it's like 7 kilometer difference and 6 minute difference. So, yeah.
Okay. So we said that his speed, the problem is we changed our units to hours. So he had a head start and a late start. Now let's imagine that they both, like, let's imagine we can go back in, right? Or back in distance. If I extended,
You said you're going back in time.
for this to happen, this would have like continued up to there, right? But we don't really care about that because when we get to graphing form, we'll care about the y-intercept. I don't know if you guys have talked about graphing form yet, but here, let's say Biker B didn't get a late start. Biker B started at the wrong place. There would be some point down here.
When he reached the start, it was after 5 minutes.
Good afternoon, Joshua Lee. Please come to the
And
office.
we could figure this out. For Biker B, what was his slope triangle? What was that triangle we had for B?
3, 2, 4.
Well, I got a lot of numbers being thrown at me.
60
What was-
kilometers per hour.
Yeah, I don't want the miles per hour. Slope triangle. What was the X? They're both 3?
Yeah.
Because that's a
Okay.
No, they're both 3.
Are they?
Yeah, the
3, 3?
It's 3, 3.
Okay. So, hold up. For every 1 we go up, we have to go 1 over. So, for every 1 I go down, I go 1 left. So, where will this point be? And that is actually going to become the value that we will know as the B. So when you think, where will that point be? This is your y-intercept point. So what we're working towards, and always I kind of give you guys a bit more because you're the accelerated class. I'll tell you where we're headed before we get there. We're working towards graphing form being y equals mx plus b. Do you remember that from science? Well,
I
okay.
did it for homework.
So remember this.
Yes. Oh, get them out of here. No, get them out of here. We love you, but those. Oh, we know B is
Easy questions. What's the growth rate? Well, if I start, well, what do we start with?
2.
Okay, we start with 2.
Y equals mx plus 2. Y equals 4.
And then we add,
4.
because then we have 6. Does this, hold on, does that work?
What do you mean?
Is there 10?
Yeah.
Like, is that true? And then is there 14?
Wait.
So the growth rate, M, is 4. The start point, how many we have when we originate. So this is why we use figure 0, even though that's like not a tangible thing.
Wait, so n is slope. So the slope is.
Sorry, not M. You guys were saying stuff online and screwing me up. Quit saying stuff online. You're like in my ear. So, this then easily answers some of these questions for us, right? Like, what will the 100th term, like how many squares will it have? Well, 402. Okay, done. Right now, I have to think about it.
So the amount it increases each time it goes up by x is n.
That gives you growth rate.
Okay, and then b is how much it starts at.
To solve like number patterns, like
X is
it
0.
adds like 5 every time, and then find the 1,000th term.
Yeah. Remember how we talked about like CPM is cyclical? We come back around and we see yours again.
Sounds like sadistic word.
All right.
How are you still full of excitement?
I lied.
That would be my friends, and they'd be like, let's track.
Which student has the most hiccups per minute? Figure it out.
Are you
Hiccups per minute.
You're like, 1, 2. Okay, that's a minute. Oh, okay. So 4 hiccups a minute. Not the whole class.
Who's got the most hiccups? Who haven't I heard from today, really? Ian, I haven't heard from you, man. What do you think?
Student one has the most pickups.
How do you figure?
Well, wait, has the most pickups. Yeah, okay. So, it says, time, number of minutes, number of pickups, and it's 2 and 8, so it's 4 hiccups per minute, and then the next one's 3.5 hiccups per minute, and then the next one's 3.8.
No, 4.
You can say what you think, but don't you dare phrase it as "Can I say why he's wrong?"
So it's when on the student 3, when it's at the 1 minute, it's at the 4 pickup mark.
No, it's
What?
no, it's not.
This is a triangle.
It doesn't matter what it looks like. The information that you've been given. Well, then that's your problem. Can I tell you why you're wrong? So, for anybody who just wanted to quickly tell Ian he was wrong, he's right. Hey, chill out. Bring it back. Bring it back. We can only have fun if we can bring it back together. This vertical change of 3.8 is denoted to you. All because it looks like it goes through 4 is not true. Okay, when it looks like it goes through the origin, we can almost certainly count on it. Like most of the time, that won't be a trick. But the grid on the graph paper can easily be misleading, especially in a computer. So trust the numbers given to you, such as 1 and 3.8. So that is 3.8 per minute. Whereas here, what's your rate per minute? 3.5. And here, 8 divided by 2 or 16 divided by 4. Any of these are 4. Annie?
Okay, what I did is I got the same answer, but since student 1 and student 2 measured in 2 minutes, I just multiplied 3.8 times 2.
Yeah, I mean, yeah, that's a good comparison. You got 8, 7, and then 7 point whatever. 7.6. Yeah.
So this isn't really saying anybody's wrong. It's really just a question. But how did student 2 start above 0 when the timer was started? Like
Maybe they didn't have any hiccups and then they started to get.
They didn't start hiccuping until 11.
Wait,
they
why
didn't
would
have
No,
time
no, no,
to
no,
pick
listen.
up.
Listen to Oliver's question.
Like they
Just
would
say it
have
again.
2 hiccups in like 0.0 seconds.
Yeah,
To be
however,
able
like
to start
this
there.
point,
So that student 2 might have more hiccups because they started with more.
be careful though, it's hiccups per minute.
3.5. Yeah.
They're asking specifically per minute. But this can't happen. And I
Yeah,
love
no.
that you noticed that because this is kind of like an Easter egg in here. Anyone who watches like Marvel films or anything like that.
Yeah.
This is one of those like, oh, let's see if your students are really turned on with their mathematical thinking. You can't have something in no amount of time
Yeah, that confused
if
me.
we're talking with the tangible reality. Now, you can have a figure 0. Now, you could also have, like, when I start documenting, my plant is 5 inches, and then it grows at whatever rate. You can have a y-intercept with real situations. But
not
this,
when it's hiccups.
yeah, this being amount of hiccups and time, that's saying whatever this number is, it took you 0 time to do that. Yeah.
If you can do that, something's up.
But if that's before they started recording, then it shouldn't count.
Oh.
But this was just comparing the rates, right? The rate of change. Lupe is a manager in an assembly line manufacturing company that makes cars. Speed at which the cars are usually built, represented here. Cars, time. Time is almost always your X.
Stop pulling out your hair, Amy. Amy, that is unhealthy.
Right now,
You want to solve this?
right now, if we talk about a standard work day, how many cars get built, and who can tell me why? Hands and explain.
I don't know. What is standard work day? 8
Will?
hours.
They would produce 600 cars in 8 hours because that's a regular work day.
A standard work day is 8 hours.
And so you just look on the graph and then you go to 8 hours and look up until there's the point is until not the point but the intersection.
Yeah, the intersection, which makes a point.
Is where 8 hours is going to and then
So, if we know that fact going in, and I'm not asking you guys to write down a bunch of stuff today, how would this impact? Would it be better, worse? What's going to happen? Who can talk about if we change the instructions to be build 200 cars every 4 hours? Sam?
Well, it wouldn't be too good because 4 hours is half the time. So even if you did only like half the time, then you should build 300 cars because 600 cars divided by 2 should be 300. So basically, you're doing less work for half the time.
So 200 cars every 4 hours would then translate to this point, if my smart board was correctly working today. And that line we can see is less steep. I guess it comes in below. What about 75 every hour? 75 every hour. Well,
They wouldn't change because what I did is I did 75 cars over 1 hour and then multiplied the numerator and denominator by 8 to get 8 hours, and it's still 600 cars. Well, then
It is.
proportional relationship. Well,
and then for C, you would be gaining more cars every work day because it's 100 cars every hour because 5 divided by 1 add the zeros.
That's 800 cars.
yeah, they then have 800 cars by the end of the workday. And then, if you just decrease the time it takes to make each car.
lower quality car. Oh, we don't know.
Well, I mean, you need more cars because.
How much time does it take to make each car?
You don't know. Oh, wait.
Yeah, we do.
Wow. Are you kidding? Of course we
You
know.
divided by 8.
How long is this going to take? 4 hours to make 300 cars.
Keep breaking it down.
8 times 6 is 100 minutes.
For the 500 cars.
So 304. What, no, wait, we already knew this,
4 hours.
right? Didn't we say this was the same?
Make hours at 60 and then divide it at 60 goes
It's 0.8333.
Be careful. Make sure you do your division correctly.
No, 60.
Oh, seconds. Okay.
Well, it depends if you're doing cars per minute or time per car.
Cars per minute, CPM.
So we were doing per time. We almost always do per time. But if they want to know time it takes to make each car, it's no longer set up like our slope. This is slope, right? But time per car is now 60 over 75, which is how you said you got what?
Oh, 1.25.
I think that's this.
I got 0.8.
0.8810.
Oh, yeah, 0.8.
88.
No, just 0.8.
No, 0.8.
You just got excited.
I said
So, hold up. Two different unit rates here that are kind of exchangeable. 1.25, what's the label on that?
Oh, that is cars per minute.
Cars per minute, 0.08
Minutes per car.
minutes per car. Now, we still got a couple minutes left. I'll get in trouble, actually, if I get police. Well, they're already releasing, so okay, yeah. I don't want to be yelled at. This is technically scary. You can keep it if you want, but if you learn, if you know everything from what just happened,
I